Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to take a look at the math and science found in nature's ratios. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI Technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. I'm excited to be joined by our two panelists, Jackie Bono and Jessica Hoot. Jackie taught for 37 years, primarily chemistry and physics. She is currently retired and consults for Veneer Software and Texas Instruments. Jackie is also the author of the TI Forensics book. Jackie, it's great to have you with us tonight.
Thanks, Mike, and I'm glad everyone's joining us. Should be a fun night.
And Jess has taught all levels of biology, from co-taught all the way up to advanced placement at Reservoir High School in Howard County, Maryland. She was first introduced to TI-Nspire technology in 2009 and has been using it in her classroom ever since. She became a T-Cube regional instructor in 2015 and actually just became a T-Cube national instructor just about a month ago, and sees the technology as a great way to help students make real-life connections with science. Jess, it's great to have you with us tonight.
Thanks, Mike. I'm excited to be here.
We're expecting a large crowd, so your audio is muted. Feel free to send any questions to Jackie or Jess using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues tonight, but in the event that you do, try selecting Communicate from the top of the WebEx menu and choose Audio Broadcast. At this point, Jackie is going to discuss our agenda.
Well, good evening. We've already done some introductions. We're going to talk about the beauty in nature and introduce the idea of the golden ratio. And we're going to introduce that both with the human body and the 84 activities that we're going to be doing. We're then going to move on to some Inspire activities, and we're going to find some patterns in nature. Jess is going to be doing the Inspire. She'll be doing some geometry pages and some drawing with coding on the CX. And then we're going to end at the very end of it. You want to make sure you stay to the end. There will be a drawing, and that drawing will be for a free summer workshop.
Jackie, thanks so much. And Jess is going to discuss our expected outcomes.
Great. So hopefully today we will observe patterns seen in nature using the golden ratio and the golden angle, use mathematics to identify certain patterns and make sense of scientific phenomena, and explore how TI technology can help visualize these patterns in nature.
Sorry about that. So, Jackie, let me give you control.
Thank you.
And feel free to share your screen.
I'm going to share my screen with you folks. And here we go. So this is nature's ratio, and it's myself and Jessica who are going to be doing this. And Jess, you want to give some words about your beautiful pictures?
Sure, yes. These are all pictures I've taken around my own neighborhood and on vacation. And so I'm always intrigued by nature. As being a biology teacher, I'm always have been drawn to nature. These are some plants mostly, and I'm terrible at identifying plants. So if you know what any of these are, feel free to put the names of them in the chat window if there are any plant fanatics out there. I'm more of, when I was interested as a young kid, I was very into aquatic organisms. Yes, there is a pineapple, very good, Tony. I was more interested in aquatic organisms, and I could tell the differences between certain fish and turtles and the difference between an alligator and a crocodile. Does anyone know the difference between an alligator and a crocodile? Put that in the chat window too. It's very, very scientific. You guys know what the difference is? Nobody? Oh, Andrew got it. One you see later, and the other one you see in a while. Oh, don't you hear all that laughter in this webinar? It's amazing. Anyway, what we're really looking for, not terrible jokes, but we're looking for patterns in nature. And so when we think about patterns, we see patterns across all disciplines. They're important for us to explore as we make observations in shapes and structures. And we want our students to identify these patterns in nature and begin to make connections and really ask questions. And so tonight we're going to be using mathematical thinking to help us describe this pattern of the golden ratio that we see so frequently in nature. So Jackie, do you want to kind of take over and talk a little bit more about that?
So interestingly enough, talking about nature, there was somebody who was watching rabbits, the story goes, and he noticed with the reproduction of rabbits there was a pattern, and that pattern is, in fact, what we got with the Fibonacci numbers. And for those of you who don't recall what Fibonacci numbers are, they're numbers where you start with the number 1, and then you add 1 to it. And so it's 1, 1, 2, and then you do 1, 2, you get 3, and then you do 2, 3, you get 5, and then you do 5, 3, and you get 8. And it is that pattern of numbers that Fibonacci created with a series, and he found that in nature. And so it just so happens that if you take those Fibonacci numbers and you divide the larger by the preceding number, you will get closer and closer to this golden ratio. And that golden ratio of 1.618 is derived somewhat from the Fibonacci numbers. And that is what we are going to be exploring. Jess said she's going to start with her nature pieces. I'm going to actually do some stuff on the 84 with the human body. And what we're going to do is we're going to do some measurements. And when you do measurements and you want to find the golden ratio, if you have any segment, and that segment is divided so that there's an A and a B, if you take the larger segment, divide the whole by the larger segment, and you come out with a 1.61, we say it's a golden ratio. And we find that both in nature that Jess was showing, and we also find that in our human body, which is nature. Now, the activities that I'm going to be doing on the 84. And all of our worlds have changed dramatically in the past few weeks. And so many of you are doing things at home and doing homeschooling or doing it remotely. And so some of these activities we've kind of taken and made it so that if in fact you're trying to teach using Zoom or some other remote means, you can do them with the kids at home. And to that end, TI is giving away the TI Smart View software for all kids and all teachers, and we'll be using that in a couple of minutes. So if kids are home and you want them to do these activities, they can use on their handheld devices free software that would allow them to use it if they do not have a calculator at home. The other thing they've developed and they're giving away for your use is they've actually developed an emulator for a Chromebook. So many schools around the country have Chromebooks. Kids are home with Chromebooks so that they can work remotely. And there is an application where kids will actually have the TI-84 on their Chromebook. So you ought to take a look at that. Mike will explain it again at the end on how to get it. So this is one of the activities that we're going to do. And I've posted 3 activities actually in the documents. One of them is an elementary, one of them is a middle school, and one of them is a high school, all talking about the human body, all talking about those magic ratios that we find in the human body, but with a little different structure. So let's take a look at one of those documents. So the first document that this is the one I'm going to do. Hold on a minute. Let me get them. Okay. So this is the elementary document. Should be the elementary document. Where is it? This is the elementary document, and you can see the type and the print and everything. I found it on TI's website. It's been changed somewhat, but it's elementary. It talks about measuring things in inches, where kids would measure it on their own body or a parent would help them measure. They then put whatever they measure into the list here and divide the numbers and see if they come out with 1.618. if you're doing something with fractions, or if you're doing something where you want kids to know decimals, that kind of thing in a math class, this is a great activity where kids are actually doing something about themselves and hopefully doing the math that you want them to do. Definitely seeing ratios in science. This next one is the one we're going to do in detail. This is the middle school activity. It's been edited. So the original activity talked about team member 1 and team member 2. This one here talks about family members. So students, if they are social distancing, are going to go and do teams of kids, and so consequently they can do any other family member. And they put their numbers on the worksheet that it comes with, and then they're going to enter them into the calculator. And as you go through, there are screens and everything for kids to do. So let's just take a look at what that activity will look like, and then I'll show you the other activity. So this particular activity, take that worksheet that I had just shown you, and it takes the data. I went and measured everything on my body. Oh, this one here is in centimeters. We will get much better results in centimeters than we will get in inches just because of working with decimals. So this one here asks the kids to measure the height from the navel to the foot of their navel, and then how tall they are in centimeters, and then things like fingers. I took that and I put it in a list. So the software that you're seeing that I'm opening is TI-Nspire. And you will see it like this when you get there. So once the kids have the data on that worksheet, then they need to type it into a list. And to type it into a list, and these directions are on that worksheet that you can download, we press the Stat button, and we press 1 for edit, and it gives us the list. Before we started, I typed in my numbers, but you literally just type the numbers into list 1 and list 2. You can use the calculator keys to do that. And then on the activity, the next thing that we're going to do is we are going to graph this data. And to graph this data, what we're going to do is we're going to have to set the graph up. So we go to second, stat plot, and we turn graph 1 on. So I'm going to hit 1. And I want to have it on. And I want to have a scatter plot. And in first list, in the X, I want list 1. In the Y, I want list 2. I want to have some kind of mark. And if you're using an 84 CE, you can actually change the color of the line if you would like. So you choose whatever color you want. So now when I hit the graph key, theoretically, I should see a graph, but I don't. And the reason I don't see the graph is, does anybody know why the graph isn't showing up? Some of you must know this already. It's the window. And so there's several ways to do the window. If you are a math person, you may want the kids to actually put the numbers in the window. If you are a science person and you're interested really in down and dirty and quick, you go to Zoom, and we do Zoom Stat, and I get my data points on the graph. You don't have to set the window. If you want to have them set the window, obviously you can. Now the problem is that that's really nice data, but we would like them to do a regression, or we'd like them to find the equation of the line. As a teacher, you can decide if you want them to do that by hand, and there's no reason they can't do that by hand. They have data points. Or you can have them do it automatically. You can have the calculator do it. And to do that, if you press the Stat key again, and if you go to Calculate, and if you go to Linear Regression, which is number 4. And so the linear regression that I want is I want X to be L1, I want Y to be L2, I'm going to do the frequency, and then I need to store the equation. So if I go down to store the equation, I need to tell it where I want to store the equation. With the update in software, used to be kind of tedious to get to Y1, but there's an easier way to do that now. So if you press alpha, trace, you'll notice that it pulls that up, and then I'm going to choose Y1. So now I'm going to take list 1, list 2, I'm going to store the regression in Y1. If I hit calculate, There's my regression. All right, so I know y equals mx plus b, so it's 1.63. That's not bad, folks. That is stored in y1 if you want over here. They put it in y1 for me. And now if I hit the graph button, I can see the regression. So that's one way to see if you are, in fact, following the golden ratio. The activity asks you to do a second person as well. And it asks you to put that person in list 4 and 5. So any other member of your family. So if I come over here, I hit the start button again, I edit, I can put their data in list 4 and list 5 and also graph their data and see if they come closer to the 1.61 if I want to. Now, the other thing that this activity asks you to do is to actually find what the ratio is between those two numbers, between L2 and L1. And so what you're going to do is what the decimal is, so to speak. I'm going to go up to L3, and then I want to take L2 and divide it by L1 because you want the whole divided by the larger section. So to do that, again, be in the top of the column, and I need to say L2. L2 is in blue over the number 2, so second 2 divided by second 1, and then I say enter, and it does all the divisions for me. On the elementary activity, you can do it this way too, have the division done for you. You could then ask the kids if you wanted to take the mean of that list and find out what exactly that number is. And again, what it asks you to do on the activity, when you're doing the activity, it then asks you to do the same thing for the second family member. So you would do the exact same thing for the second family member as well. I'm not sure if there's a whole lot of questions yet or not.
So there have been some questions, Jackie. So one of the questions that I saw a while back in the chat was kind of describing the levels for each of the 3 activities, and if you could go over that again.
So the elementary activity, and you're going to see it when I get to the high school activity. The elementary activity has the kids do measurements and then divide the two numbers and see how close they can come to 1.61. So it's a case of just division of two numbers. They can enter it into the calculator as we did here. The directions are there to do that if you would like, and just get the ratio. The middle school activity gets into a little bit of graphing, either graphing by calculator or graphing by hand. But again, you take those numbers, you look at the ratio, but you also graph it. So you see graphically what those lines look like. Then the high school activity, which I'll show you in a minute, actually gets into the statistics behind it. So you actually find quartiles and everything. There's no reason why any of these activities can't be done wherever you want them to be done. The only problem I have with the elementary activity is the size of the font looks young. I would feel uncomfortable necessarily giving that to, even if it was a low-level high school student, I would take and change the font on it just because it looks young, and I think it would be insulting to kids to get that.
Right. And then someone else wanted to for us to repeat and explain the relationship between Fibonacci sequence and the golden ratio.
So the Fibonacci sequence of numbers supposedly is based on rabbits. It's a ratio that he found. And in order to get the golden ratio from the Fibonacci numbers, if you take the numbers and divide them, so if you take I got to pull the sequence up again. I just lost it on my machine. Hold on. So the Fibonacci sequence goes 1, 1, 2, 3, 5, 8, 13, 21, and it keeps on going. So if you take a look at 13 and 21, take 21 and divide it by 13, and as the Fibonacci sequence keeps going up, it gets closer and closer to the golden ratio. So initially, 1 divided by 1 is 1, and then 2 divided by 1 is 2, and then 3 divided by 2 is 1.5, and it keeps getting, as you keep going up, it keeps getting closer and closer to the golden ratio, is what happens. So let's just take a look for a moment at that high school activity, or the activity that I'm calling the high school activity for a moment. And that's actually directly out of, oops, that's the end. So this is directly a TI official activity that I just took, but it does a nice job, again, if we're looking at homeschooling students, and I'll talk to you about why that is. And so they talk about an 83, and an 84 is the same. It's out of one of the very old exploration books, and it talks about Mona Lisa. Mona Lisa's phase follows the golden ratio, talks about pine cones and sunflowers. Gives you an idea as to how that golden ratio is done again here. So it gives you some really good background information. It tells you how to measure, do some measurements on your body. Again, we are in centimeters. If the kids do it in inches, it's a little bit harder to get close to the numbers. And it goes through all of the steps to go through, just as I talked to you about doing that, except that this one here, as I go on, talks about doing the maximum, the minimum, the mean, and this is just doing the graphing. So they set up and do the graphing. And then they do a, instead of doing back here, we did the scatter plot. What they're doing is the box and whiskers on this one. So I always hear when I work with teachers that statistics is an area that in high school, they're expected to do a whole lot of statistics on state testing, and teachers don't necessarily feel as well prepared as they would like to. In the state of Massachusetts, interestingly enough, the 84 is the calculator on the state test. So knowing and doing these activities help kids on state testing. When your kids have to do state testing, obviously this year they are not. So this is the box and whiskers. And then it goes through and tells you how to do it. Now, the problem with this activity, very honestly, in the state we are in right now is it's not easy for kids to get a whole lot of data because they are supposed to be isolating themselves. But it is an official TI document. And so there are great teacher pages. And so this is their data table. But if you go on to the teacher pages, you will see that they give you all of this data. So you could send out this activity for your students, and they could do it at home because you could give them the data table. And by doing that, I wouldn't ask the kids to do all of it. I mean, I would tell, it's kind of an interesting thing when I have a whole lot of data. I sometimes say to them, take any 15 pieces of data and use it. And then somebody else will choose a different 15 pieces of data, and let's just see how close it is to matching. So if I were doing it with kids, I would tell them to choose whatever data they wanted to choose. So many pieces that you chose for them to do. And then this is all of the answers, and they actually aren't giving me the picture, but they give you all the answers here in the teacher notes. A word of caution, never, ever, ever send kids to the TI website to get these activities. Hand these activities out to kids because the teacher pages are also available to the student. And once the first student discovers that on the TI website, you will have amazingly good data coming back to students. Any other questions? By the way, although I'm doing this on the 84, all of these activities can easily be done on the Nspire. That's not true for the reverse, but these activities with the human body with kids can easily be done on the Nspire as well as the 84. And they are, Mike has them to download once the webinar is over.
Yes, and those were some of the questions that were coming up is if this could be done on the Nspire and where the documents are. So
yes.
We've been trying to address those in the chat. But yeah, you'll get the documents and we can do this on the TI-80 or TI-Nspire as well.
Right. Other questions? All right, I'm going to go ahead.
Yeah. So there was another thing I saw was someone was asking about if in the teacher documents they would get information how to create the graphs on the TI-84, and I believe that is
yes,
correct.
They are. All of the directions to create those graphs are there. The one I did is there, and then on the high school one, it's there from TI. And then I also gave the directions in teacher notes in the elementary one. I didn't give kids notes on the elementary one. I think it may have to be more teacher driven is my feeling, but that's just where I'm coming from on an elementary person.
And again, we'll find these documents at the end of the webinar. You'll get a link with all the stuff that we're using.
Right. All right, I'm going to stop sharing, I hope. I think I stopped sharing. And now I'm going to bring the ball to Jessica, we hope. And, all right. Let's drag you that ball. I think you have it, Jess. Do you have it? No?
Not yet.
Okay.
There you go. All right, and so I am going to be talking about the TI-Nspire CX. So I am on the TI-Nspire CX Premium Teacher software. And again, this is one of the things that you can download for a free 6-month license right now. Your students can download the student software. There's an iPad app. And so I'm going to show you some activities you could do with your students using this platform. And so being stuck at home, I've been trying to get out a little bit more, walking around my neighborhood, and this webinar has been kind of a treat to kind of get my mind off things and really bring out my own curiosity about how mathematics and science are related. And on these walks and around my house, I keep looking at things a lot differently. And if we can even put an ounce of curiosity in our own students to have them start thinking about some of the things that they are experiencing in their own worlds, you know, that's what teachers all want. So I have a blank page right here, and in the TI-Nspire CX Premium software and any TI CX calculators, you select pages. And so I'm going to start with a geometry page. So I'm going to add a geometry page, and in the software you can see a blue line. They're color-coded. And I'm going to add an image. So you can kind of send your students on a scavenger hunt for things that you think or that they think represent the golden ratio. And so I took some pictures and I saved them to my computer, and I'm going to insert images that I have here from the insert bar at the top. So I have an image that I want to see if it fits the golden ratio. And so I have my hand. And so I can use the geometry page to measure segments of my hand and see if it fits the golden ratio. And to do that, I'm going to hit the menu button. In each of the pages, there's going to be the menu button, but they're going to have different menus for what you want. So I'm going to start with points and lines, and I'm going to add a segment. And from here, I'm going to use this point and click on the tip of my finger and bring down the segment to the base of my finger, and then click again at the base of my finger to my wrist. So I want to see if there's going to be a golden ratio proportion between my finger and my hand. And so I can use the software to measure these segments. I can measure the length, and if I just click on the segment, the value comes up. And I click on the long segment, and here is the value. And then I can use this to calculate the ratio. And to do that, I go to Actions, and then I have to type in what I want it to calculate. So I'm going to hit or click on A over B because I want to do the long segment over the short segment to see if that fits the golden ratio. So from here, now that I have that, I can go back to Actions and hit Calculate. And if I click on the expression, I then can select my A value and select my B value, and I come up with 1.51, which is a little short of the golden ratio. But what I can do is I can move this around. I can check to see which of my fingers might fit this ratio a little bit better. So I can look a little bit at my index finger and see if that fits at 1.61. It's a bit closer, so I call that a win, to see which of my digits are the most golden by doing something silly like this, to see how we can see some of these golden ratios in nature. And so you can either have your students take pictures, upload them, use this student software to manipulate it, or you could have the students send you the pictures. You can vet them ahead of time, of course, and then go through them. You know, at this point, if you are distance learning and you have some sort of screencasting tool, you can do this together as a class. Or if you're in the classroom, back in those days, it seems so far away from now that we did this, but if you had a navigator system, you could send these pictures out wirelessly, and they could manipulate them on their handhelds. So there's a lot of different things you can do with that. So on my nature work walks, I see a lot of flowers. Again, I'm not a super botanist flower identifier. This is actually a plum blossom from a plum tree. I had to use an app, a crowdsourcing nature app, to figure that out. So I live in the Baltimore, Washington metro area, and so Washington, D.C., as you might know, is very popular during this time of year. We're a little past the peak of cherry blossoms. And so there are several cherry trees in my neighborhood because even though they're not native, developers like to plant them because they're pretty in the spring. And some of these flower petals also, and a lot of other flower petals, also exhibit numbers from the Fibonacci sequence. So these flower petals, there are 5 per flower, which goes with the Fibonacci sequence. And there are a lot of other flowers, if you pay attention and look at patterns, that have this sequence as well, that are found either in 3 or 5 or 8 or so forth. And so what I wanted to do with the flower is I also wanted to talk about the golden angle. So the golden angle is the angle of rotation seen in many natural phenomena. And to get the golden angle, you divide the degrees of a 360-degree circle by the golden ratio, which is 1.618. And you get 222.5 degrees for the larger section, and then 137.5 degrees for the smaller arc, which is the golden angle. So 137.5 is the golden angle. And so what this is important in nature is that you're looking at this phenomenon called phyllotaxis. And phyllotaxis is how leaves rotate around a stem, and how flower petals rotate around the center of a flower. And it's pretty fascinating. And so we're going to use this picture to find if this exhibiting this golden angle. To do that, we're going to draw some more shapes, and we're going to draw a circle. And so to do this, we start with the center, and we move outwards to create our circle. And there we go. And then you can right-click on the circle to change the color if the background color doesn't quite work. I'm going to make it white. And then we're going to draw some segments like we did before. So starting with the center and going up to the midpoint of this first petal, and then down to the midpoint of this other petal. And so we've got this long arc over this short arc, and then the golden angle, if this is meeting that golden angle, should be our 137.5. And to do that, we can measure the angle, and we just click on the point, and then the center point, and then there you go. And so it gives us 139. So not too bad, but this one's a little bit different. So it's not quite in the center, so if we manipulate it a little bit, see. So you can manipulate these points too, like I did with my finger. So if I make this a little bit more in the center, there is, oops, had it at 137. There you go. Now, see. There we go, 137. So you can see that as the petals turn around the seed head, you get this golden angle. So do we have any questions or anything so far, Jackie?
Yeah, they were wondering if you could spell the word that you mentioned.
Oh, sure. Phyllotaxis?
Yes.
So it's Phyllotaxis.
And the other point that's come up, and Mike's chatted with them about it, is how easy it is to insert an image.
Yeah, as long as it's saved to your computer, all you have to do is click on this menu, and this button here will bring you to whatever file you have it saved to. So I find it really easy to do it. And you know, it's a great way to manipulate and kind of explore some of these natural phenomenons, because if you can bring them into your devices, then you can really show these mathematical connections. I think it's pretty cool. Anything else?
No, and again, this software is available free to kids right now and to all of you. So what Jess is doing, your kids can do at home.
Yep, we sure can. And so the next picture I wanted to show you is actually from my home. So when I was looking for ideas for this webinar, I was just, again, becoming so curious about, okay, what could here represent the golden angle or the golden ratio? And this is a pineapple plant. And so about a year ago, we decided to plant a pineapple where you take the top of a pineapple off and you put it in water for it to grow a little bit roots, and then you put it into soil, and it's about a year old, and it takes about 18 months to grow or to fruit. So in 6 months, we might have a baby pineapple. So it gives you an appreciation of, like, when you eat pineapple, how long it takes to just get one. But the leaves of the pattern, or the pattern of the leaves as it forms around the center of this plant, also have this 138, or you can round up from 137.8 or 0.5. And pineapples themselves also have some of those spirals, the golden spirals on the scales of the pineapple that rotate around in Fibonacci number sequences, which is pretty cool. So there's a lot that you can do with looking at the world around you. Do a little scavenger hunt in your house. Take pictures of them, put them in your calculator, and nerd out by trying to find the golden angle or the golden ratio. Your kids will think you're the coolest person ever. At least mine do, because, you know. Another thing I looked at were these golden spirals. So looking at that phyllotaxis process where you have these rotating seed heads, a lot of the times you see those spirals happening in opposite directions, a clockwise versus counterclockwise pattern. So this is a pine cone. And so it almost looks like an optical illusion. And so there are, in pine cones, there are 8 counterclockwise spirals and 13 clockwise spirals. And so 8 and 13 are both Fibonacci sequence numbers. Again, pretty cool. And this is a seed head for pine trees. And so, you know, as a science teacher, the math is cool, but also the thinking about why. What is the advantage of this type of phenomena? So, you know, is it for seed dispersal? Does it help with seed dispersal that this pattern is frequently found in nature? And so for this next segment, and before I go on, was there anything else before I get to the next part?
No, but there was a comment that it's kind of fun not to find everything golden.
Yeah.
And obviously there's lots of things we see in nature that are not golden, but there's a whole lot that we see that are.
Right, and that's the cool part about it is that there are certain things that do fit this pattern that, make us wonder why, but then there's also things that don't, and then even things that are supposed to, there's still some variation because, we all have DNA, we all have genetics, and those genes are expressed different ways. So it's all going to be a little bit off, essentially, which is the nature of, being alive and having cells. So when I looked at this pine cone and I was thinking about this webinar and what I could do to show you guys how cool nature is and some of these mathematical principles, I came up with the idea of writing a program. And the CX2, the TI-Nspire CX2, now has a draw feature. So you can make some graphics. And so I wanted to draw these spirals. And so I wrote a program to show these crisscrossing spirals, these counterclockwise and clockwise spirals. And so I am, just to give you fair warning, I am a novice coder. So I have never taken a computer science course. The only coding classes I've ever taken were what I did with 10 Minutes of Code on the TI website. And so there is now Unit 6, which is the draw function for the TI-Nspire CX2 that I followed and did on my own. And then there was a couple webinars that I watched. There was one for the 2020 virtual T3IC, the T-Cubed International Conference run by John Hanna with the draw feature that I watched. And I just kind of figured it out. And so I'll kind of walk through the program to kind of tell you what I did. With the amount of time we have left, I'm not sure if I could actually write the program for you. But you'll get this TNS file so you can play with it yourself if you choose to. And the other thing I did, there is a document that will be with that bundle of documents you'll get at the end that is called the Pinecone Code Decoded. And so because I am so new to coding, I really like to break things down piece by piece. And so I have a document that I've kind of broken up the code line by line to kind of explain to myself why it's there and what it's doing. So if you are into coding and this is easy peasy stuff for you, then you probably don't need it. But as someone that's kind of getting into it as a novice, I just find it helpful to do it for myself. And so I looked at some other people's code and kind of thought about, well, they did it this way, so maybe if I did something, I could do it something, maybe it would work out. So in the draw function or the draw page of the CX2, so just to kind of show you what it looks like. So this is a program manager page, and if you hit menu with the CX2, now you have this draw menu that you have available to you. And so I'm just going to show you some of what I wrote and kind of explain what it's supposed to do, and then show you the program. So in this, we have to set the window. So we have this canvas that we draw in. And the canvas goes from, if we look at the left-hand side of the screen, like the x-axis would go from 0 to 318. And then, so that would be from left to right. And then from top to bottom, it would go from 0 to 212, so based on the number of pixels and just the size. So what I did is I kind of centered that by the set window. That's the X-min. So this is X-min, X-max, Y-min, Y-max. And so that was just kind of drawing the parameters of what my code will do. And then everything else, for the most part, is defining variables. And so I've defined variables, and I put in a for loop, and that's about it. So, but it was a struggle for me. I'm very proud of this code because it was very frustrating to write. It was a lot of trial and error, and when I finally got it, it was very rewarding. And so I'm going to build it up, and I hope it I hope the result is as cool as I think it is. So the C value here, what I'm defining C as is the constant scaling parameter for the amount of space between each spiral of the pine cone scale. And then this is the golden ratio and the golden angle, and those equations are using the quadratic equation to solve for them. And then S is going to be the radius of each pine cone scale. And the total I take from those spirals. So there are 13 clockwise spirals and 8 counterclockwise spirals, and multiply those together will give us total number of pine cone scales. And so those are all the variables that I'm going to be using for my for loop. And so those are all defined ahead of time. So for my for loop, what that means is that we're going to have for each pine cone scale, starting at 1, and then we're going to end at the total, which is 13 times 8. And then our A is going to be our angle that each pine cone scale in polar coordinates that's going to increase by the value of the golden angle. And then the R is going to be defined as the distance from the center to each pine cone scale. And then we, of course, have to make the pine cone brown. So I set the color using an RGB value, and I played around with the numbers a little bit to get a brown color to match my pine cone. And then the fill circle, what I'm using here is I'm converting the polar coordinates to Cartesian coordinates, X and Y, and then drawing the circle for each pine cone scale with the radius of 6, which I had previously defined as S. So, you guys ready to see the results? It's mind-blowing, just letting you know. So to run a program, so hopefully you followed along with me of what this all meant, but we hit Control R, and that will open a new page with my program name, and here we go. Here's the final result. Ooh, it's my pine cone. So I see oohs and ahs. Ooh. But
lots of oohs and ahs.
If you look, you can even count. I can see it clockwise. The counterclockwise, I can't quite see. But if I start down here, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 clockwise spirals. Woo woo. So, yeah. So being able, and I mean, there's a lot of math in here, right? So math teachers, like, do you feel like having students apply this type of equations to coding be really useful for your students and really bringing another aspect to demonstrate their understanding of the natural world? I think it's, being able to take science and math and put it together and create art is pretty awesome. So I'll draw that again because it's just super cool. All right, any questions out there for this?
Math teachers are very impressed.
Oh, yay! As a biology teacher, that's like, this is a proud moment. All right, so what I guess we wanted to kind of do a few shout outs and thank yous. And so our final slide, oops, that's not it. That's my calendar. We want to kind of take a look at thanking you guys for coming to the webinar. And I hope you learned a lot. I wanted to share this picture because this is very special to me, and give a special shout out to my 11-year-old fifth grader who, as I was sitting at the kitchen table kind of doing some research and all this, he asked me what I was doing because he's just a curious 11-year-old, and I said, well, I'm doing a webinar on nature's ratios and the golden ratio and the Fibonacci sequence. And he's like, oh, we learned about that in math class. So he told me he would teach me. And so he got out a piece of paper and started writing the sequence for me, including of a pine cone. That gave me the idea to do the code for the pine cone because I thought that would be pretty cool. So shout out to Howard County Public School Systems. You guys are doing a great job. And possibly the 23 chromosomes that I gave him as well. You know, he's a smart cookie. So thank you to Jackie and everybody else for coming tonight. I really appreciate everyone being here, and I hope that you guys had a really good time. And are there any other questions, Jackie?
No, one of the interesting thoughts was there's a couple interesting thoughts. One was, could you do the spirals in one direction in one color and the opposite spirals in a different color?
That's a good question, and I don't know. The great thing about this, though, you can play around with it, and I'm sure there's people with a lot more experience than I am with coding to kind of figure that out. And the great thing about this is I just enjoyed playing with the variables. So looking at, you know, just what happens if I change the scaling. So going to, let's say, 9 and then running it. And it looks a little bit different, not much because I only changed by 1. But let's go with 5. And now they're all kind of on top of each other. And so you can look and see how, you know, if you change one part of it, what it do. So we can make the radius a bit larger. If it matches the scaling, then you get all these other crazy things.
Another interesting suggestion was if you could have superimposed that on the pine cone you had there.
Yeah, and I don't know how to do that. But that was one of the things I was trying to figure out, but I don't know if I'd have to have another program running simultaneously. But that would be something really cool and something that I was thinking about, but I just didn't have the experience or the knowledge to do that at this point. But yeah, that would be really cool to be able to superimpose this directly onto this, to see how accurate it would be.
And of course, the nice piece of that is that if you put that out there and you gave it to a student, we all know one of the kids could do it.
Oh yeah.
Right.
They run with this stuff way faster than I can ever pick it up. But yeah, every time I've introduced coding in my biology classrooms, and it's like I teach them a tiny fraction of it, and they deliver, you know, a whole bunch more. They're just amazing at this. They're so talented. It's great. But yeah, there's definitely a lot you can do with this, and I feel like, you know, as challenging as this particular program was for me, I feel like it just scratched the surface of what you can do with it. So, anything else?
The other interesting thing that's just been popping up is there appears to be a golden ratio in music, which might be neat to explore too.
Yeah, that's something that you could really get into. You can play music with, or you can program music using frequencies, and that would be really interesting to see and hear. All right. Anything else?
No, that seems to be it right now. Oh, somebody just said there's a webinar on music coming in 2 weeks.
There you go. Maybe they'll talk about the golden ratio found in music.
Maybe.
All right. Well, Mike, you ready?
I'm ready. Thanks so much.
No problem. All right, here you go.
Thanks so much, Jackie and Jess, for everything you shared. If you have any last-minute questions, please try to get those asked. I know they'll do their best to get those questions answered. A couple things I want to share available on our website, education.ti.com. First is if you move on to the Professional Development tab and slide down to Webinars in the middle, and go to Live TQ Webinars, So I know some people were just asking about music and the Fibonacci sequence and the golden ratio. If I had to guess, the webinar on the 21st is going to be talking about all of that. So if you're interested in learning a little more about everything that we talked about tonight and then some, feel free to register for our April 21st webinar along with some of the other webinars that are upcoming. And if you hop back to the on-demand list of webinars, this is a great place that if you're maybe just getting new to some of our software or you want to learn more about maybe some STEM fields, if I want to drill down onto a subject area and I pick, say, STEM, for instance, I can look at all the webinars that we've recorded that just focus on STEM. Or if I want to look at a webinar that we've recorded just on using the TI Smart View software or the Nspire, I can do all of that. Second thing I want to mention was as far as if you're looking to get this software for yourself or your students, I know Jackie and Jess have talked a lot tonight about what Texas Instruments is currently trying to do to make that available to everyone. In a few minutes, you're going to get a documents link from me, and whenever you open it up, it will look like that. And as far as the free software piece of that, you're going to want to click on the pre-event slides is one way to do this. You can also get all this available from our website as well. But if you go down a couple slides, there's some information about the free software and what's available for the 6-month license, and then more information about the iPad apps that are free until the end of this month, as well as if you're looking to get the Chromebook app, there's a link for that as well. Another piece on our website is you can look and see what current TQ summer workshops are coming to an area near you. They're really a great place to, for instance, spend more time learning about coding. Jess said she's kind of a novice in coding. I just learned that I'm way more of a novice than Jess is at this point in coding. So, you know, attending a TQ summer workshop gives you that time to learn a little more about whether it be maybe a piece of content or technology. So it's a really great place to sharpen those skills and keep them fresh. So please visit our website to learn a little more about some of these upcoming TCube summer workshops. Some of them are face-to-face and some are virtual. And we also mentioned that we're giving away to one lucky winner a TCube summer workshop. And tonight's lucky winner is Nicole Gauscher. So Nicole, congratulations. We hope to see you as well as everyone else at TCube summer workshop. And Nicole will be in touch over email in the next couple of days to get you a little more information. To receive a certificate from tonight's webinar, go ahead and click the link in the chat window. Also listed is a link for the documents from tonight that I just mentioned. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. And if for some reason those links aren't working for you right this second, hang tight, you'll automatically get a follow-up email in a couple days, and in that follow-up email will be links to the recording, the documents, and the certificate as well. Lastly, if you're in need of any post-webinar follow-up, give us a call at 1-800-TI-CARES or send us an email, ti-cares@ti.com. We'd love to hear from you. So thanks so much, Jackie and Jess, for everything you shared tonight. It was really exciting. To see all the comments and questions that came in. So thanks so much.
Thank you.
And thanks everyone for joining us. It was definitely a lot of fun. We had a lot of people join us for the first time tonight, so it was exciting to see so many new people on. We hope to see you back online next week. Have a great night, everyone.